My name is Brian Caffo, and welcome to this week's Ask Brian part of our weekly newsletter. You can sign up for the newsletter in the video description below. Also, there's a link to submit a question. I'm also on Askers if you want to kind of guarantee that I'll answer a question. This week I picked something that's kind of very familiar to those of us that work in biostatistics. And someone asked, what's the difference between a mediator and a moderator? And there's a lot of stuff on the internet about this. And I'm going to omit a kind of important discussion of how this plays in with the field of causal inference. I'm going to discuss the more kind of practical mediation moderation discussion that occurs that is kind of more historically, not the modern treatments that you see about mediation, especially with causal inference. Okay, so I'm going to do this in the context of an example. So I worked on a study where we were looking at lead exposure and brain function. Okay, so the investigator was interested in how lead exposure impacted our brain function. For example, you get high dosages of lead cumulatively might impact your memory. So imagine there were some genes, kind of genetic state, where if you had a certain set of alleles, you were highly susceptible to the effects of lead. And if you had the other set, you were highly resistant to the effects of lead. So I would call that more of a moderation thing. I don't think it's for sure true that your lead exposure isn't affecting your genotype. What we're saying is there's a lead effect among people with a certain kind of genotype, and there's a different lead effect, or maybe no lead effect, with people of a different kind of genotype. Okay? So that's kind of what moderation, we're saying, this idea the genotype is moderating the effect of lead on brain function. It's changing the effect. Okay? And it's usually done, moderation is usually looked at via interactions in regression models or logistic regression or generalized linear models. So usually moderations is sort of looked at through interactions. So if you want a really simple rubric of thinking about moderation, if you're interested in an interaction, then you're really investigating moderation. Now, mediation, to me, I think to really think about mediation, you have to be thinking about mechanisms. So, for example, if I wanted to look at lead exposure, how it impacts brain function, but I wanted to know how. I wanted to know the mechanism through which that happened. I wanted further details into the mechanisms of how lead was impacting brain function. And maybe I collected MRIs, and I could look at brain volume, localized brain volumetrics or morphometrics, which is the kind of things that I do, volumetrics. So, for example, lead shrinks your hippocampus. Your hippocampus, having a smaller hippocampus means you have a worse memory. That's not exactly how it works in this case, but as an example. Okay, and then we might still leave this other arrow here because we might think there's ways other than brain volumetrics that lead is impacting brain function. It might be through some other aspect of the brain, some sort of chemical, some sort of more chemical factor rather than volumetric factor. Okay, so what we're saying here is that the lead exposure then causes a change in brain volumetrics, which then causes a change in brain function. So we're saying the way in which lead exposure impacts brain function is mediated through brain volumetrics. So we're really interested in that more mechanistic understanding of the problem. And so we have to approach this with a different kind of algorithm because it's a more complicated question of whether or not there's just moderation going on. Okay, so one way to do this is with path diagrams. Another way to do it is sort of full causal style analysis, but let's talk about path diagrams. So what we might do is have a model that says something like brain volumetrics is a function of lead exposure plus some other covariates that impact brain volume, and then that brain function is a function of brain volumetrics plus lead exposure plus other stuff. Okay? So this first equation, equation number 1 here, that's modeling that arrow. And the second equation, equation number 2 here, that's modeling this arrow through the fact that we have brain volumetrics in there. And it's modeling this arrow by the fact that we have lead exposure in there. Now it's interesting that our two models here, they're not exclusive, right? They could, for example, we could think, well, the change in brain volume is the part that's actually mediated by the genes. So if we wanted to investigate that, we could have lead exposure plus genes plus lead exposure times genes to put an interaction in there to investigate the nature of how the moderation is occurring. Okay, but I think this example highlights the difference between when you're looking for moderation, you're not, the moderator isn't the change agent, it's just a variable for which different levels of it will impact the relationship between the independent variable and the outcome, versus mediation where you're really kind of trying to get at mechanistic roots of the problems, and you're trying to wonder, is the way in which the independent variable impacts the outcome, does it go through this other variable? Okay? Well, I hope this example helps clarify this question a little bit. If you get a chance, subscribe, and I'll have another video for you next week. So see you then.